Good morning, or maybe it's afternoon. I'm not sure what time it is. Still morning? Still morning. Okay. And I am conscious that we're running a little bit short of time this morning, so I think I'm just going to kick right off. But thank you very much for the invitation, and I'm so happy to be here. So I have spent the last maybe about 10 years working primarily in mobile. I started in mobile really, really early when phones were teeny tiny. And a lot of what I did is I worked with companies of all sorts of sizes. And what I often focused on was helping people understand that mobile was not so much about devices, it was more so about people and all the many things that we do with these devices and how they change our lives. And mobile has really changed. I mean, it's actually been pretty amazing how quickly it's gone from almost no one having a device to now, there's 3 billion of us now connected, and a lot of it is down to mobile. And throughout all this time, with all the apps and everything that's happened, really mobile and the web still remains the best way to reach everyone, right? If you want to reach absolutely everyone, the web is the way to go. And so what I want to talk about today is, and hopefully kind of get you thinking in the right mind space about, there's this huge opportunity that's coming up that's going to sit at the intersection of mobile and the web and the physical world, and that's kind of what we're going to talk about today. So got a bit of a delay there. A few months ago, I ran into this on Twitter. It was nice people at the View Source conference, and they were asking around, what do you want us to cover this year? And service workers, WebAssembly, IoT, they had thrown a couple things up there, and they got about 130 replies from people. And as you see, IoT was way down at the bottom. I mean, 11% is pretty grim. And pretty disappointing, but the thing is, it's actually not that surprising, right? I run into this a lot, and what's kind of weird is that, hopefully the picture isn't completely disintegrating on me there. I mean, IoT is huge, right? People talk about connected devices, the estimate, and there's a lot of estimates out there, but even if these numbers are kind of wrong, right, they're huge. Within less than 10 years, we're going to have 100 billion connected things of some sort out there. That's a lot of devices. But the thing is, when I talk to people who build for the web, often I get this kind of a bit of a disconnect, right? I mean, a lot of times people who build for the web, they don't really know where they fit into IoT. And IoT is already huge. The ecosystem is absolutely gigantic, and it touches all these different parts. There's like healthcare and industrial and all these different things. But because I think it touches so many things, everyone is developing their own mental model and their own definition of what it is. And I see this quite a bit. You say IoT, and everyone has a different kind of feeling. Somebody goes, oh, well, it's drones. And other people say, no, it's robots. And other people say, no, it's Fitbits. And in some ways, it is all of those things. And that's what makes it a little bit hard to grasp. But the common thread, though, if you do stuff for the web, is that the web right now is kind of missing throughout a lot of this, right? It doesn't really touch the web very much. And part of it is just at a pure, level of interacting with these devices, it's really still quite rare to find a web interface that enables you to have any sort of way to interact or control or even just barely look at the data coming off of all of these different devices, right? Whether it's a home automation system or a smart appliance or a drone. Wearable sensor, lots of different types of sensors. I love this one. Convoys of autonomous vehicles. We're talking about so many different types of objects that are going to be connected. And then we're even, starting to look at things that you don't quite know how to define, but they're definitely here already, and then they're coming, and right? And there's so many variations, and for almost every example that I showed you there, anything that was vaguely consumer level, there's probably some industrial equivalence to it. And there's B2B and there's healthcare, so it touches so many different areas. But again, the web, not quite so much at the moment. So part of the reason this has happened so far, and there's a lot of different reasons, but a lot of it has been down to technology gaps. As we know, standards, sometimes they move really quick and then other times they don't. And there's also just some, when you're dealing with devices, especially the smaller the devices get, right, like these little beacons that Robert had earlier, I mean, you know, there's some very, there's some big concerns around battery life and around the amount of power that these things draw. And so connecting these things to the internet is not necessarily always an easy thing. So all of these things have contributed to an environment where the web hasn't really connected to these devices yet. Now, beyond the technology gaps, though, there's also often human gaps, right? I mean, there's a lot of reasons why technologies don't always develop at the rate that you'd like, and a lot of it sometimes has nothing to do with the tech at all. And so to better understand what's maybe holding, not so much holding IoT back, but in some ways holding that intersection of the web and IoT back, I'm going to start by looking into the past just a little bit. And I will start with this guy, who's Mark Weiser, a scientist at Xerox PARC, and this was way back in 1998. It's been quite some time now. And he first coined the term ubiquitous computing, which is kind of the original term for what we now kind of call the Internet of Things and connected devices. And the way he foresaw it was pretty similar to how we look at it now. I mean, his idea was that at some point the world would be networked and there would be millions or billions, as it were, of connected objects, and a lot of them would be collecting data and then spitting it out. And you know, when they spit this data out, it could either go to another machine or it could go to a human being, and then something would happen, right? It's kind of this cause and effect gather. Somebody grabs the data and then you do something, hopefully something really neat with it. And that's been the vision. And there's kind of a parallel between IoT and the early days of mobile, because it's pretty easy to very quickly fixate on devices and you know, to get really excited by all these different types of things, whether it's a fitness tracker or a drone or anything really. It's easy to look at the devices. But ubiquitous computing, certainly the way it was envisioned at the beginning, and in my opinion, the way it needs to kind of continue in the long term, it was never really meant to be about devices. It was still really about people. And when you look at this quote from Mark Weiser, I think this kind of tells it really well. I mean, even though he's talking about VR, which is kind of an interesting parallel, he said ubiquitous computing is roughly the opposite of virtual reality, and where virtual reality puts people inside the computer-generated world, ubiquitous computing, it forces the computer to live out here in the world with people. And I really like the use of the word force, because there's always this tension, right? Even today, even with devices that we're so used to, like smartphones and our laptops and so on, there's always a tension between the relationship between the person and the device, and how the device affects everything that you do, and you know, even the fact that it's always on and that you're always connected. None of that is a natural state, but it's becoming our natural state. So when you look at some of the early UbiComp experiments, a lot of them are really quite crude, as you can imagine, things we're looking at, you know, 1990 era. But you can start to see fragments of these relationships in some of these first experiments. So I'm going to go through just a couple of them. The very first thing connected to the internet, as far as anyone can tell, was a toaster. There's always a toaster in these stories somehow. And it was connected by John Romkey and Simon Hackett. And it was kind of a dare. I think someone said to them, let's see if you can do this. And so they went and they put it together. And so they had a toaster, they had a switch of some sort, and they had a bunch of cables, and it was connected over TCP/IP. And it was a really simple thing. All it really did is you would send a signal and it would turn the toaster on. And then you could send another signal and it would turn the toaster off. And that was it, right? If you wanted darker toast, you just left it on a bit longer and then you turned it off. And that was all it did. And you know, but still, this was 1990, and Romkey was actually one of the co-creators of TCP/IP. So in some ways, he was just, you know, he was playing around with some of his own technology and what can we do with this? How can we connect it? Second object, so this was just 1 year later than the toaster, was a coffee pot. Now, this was a coffee pot at the University of Cambridge, and it was in a room called the Trojan Room. That's why it's called the Trojan Coffee Pot. And this was kind of a communal area at the University of Cambridge where everyone would come down from all the different parts of the uni and they would go get their coffee. And what they found was that they had a frequent problem, as it is with coffee pots, is you would show up and there would be no coffee. Somebody would have taken the last bunch and not made it. And so they took a camera, they placed the camera in front of the coffee pot, and they had it take pictures at regular intervals and then broadcast them over the network. And then everyone at their desk could see this little tiny, tiny picture, grainy little picture of the coffee pot. And it would save them the trip. If the coffee pot was empty, they would just wait until they saw it fill up again, and then they would go off and get coffee. And that's what they did. And it actually, initially, I can't remember what network it ran over at the beginning, but very shortly thereafter, they actually put it on the web. They actually had it running through one of the first browsers. So this was in operation for a little while. Now, the last item I want to mention is completely different from the others, not techie at all. This was a kind of an art project by a person by the name of Natalie Jeremienko, and this was 1995, so a couple years after the others. And what she wanted to do, she wanted to create kind of an ambient representation of something that people could look through in the office, right? So what she did was she had a long, they called it a piece of plastic spaghetti, but if you can imagine, it was a long string kind of made out of plastic. She put a motor on the end of it, attached it to the ceiling, and it would track the amount of network connectivity going through the building. And so if a lot of people were using the network, the motor would spin, and then the piece of spaghetti would start kind of twirling around. And regardless of where you were in the office, as long as you had line of sight of this, you could see what was going on. And then if it was really quiet, it would quiet down. And so again, this was it was a bit of an art project, but at the same time, it was one of the first examples of what we now kind of refer to as a glanceable interface, right? A calm piece of technology that's not meant to intrude on you. It's something that's in the periphery, and you can kind of, peek over to it, and you can understand that something's going on and get a bit of information from it, but without buzzing or lights or anything that would intrude on your day. So when you think of these three objects, I mean, there's kind of, two of them kind of stand aside in a different way. I mean, Romkey's toaster, in all due respect to Romkey and his experiment, it was very much a toy, right? Matter of fact, he was dared to do it. So it was kind of like, let's see if we can do this. The whole goal was, can we connect this thing to the internet? And so in that sense, it was more about the thing and what you could do with it than it was about the actual people who would use it. And when you think of the other two experiments, the questions that they asked were probably a lot less well defined. I mean, in some ways, it wasn't so much about the question. It was about what they did and why they did it. And that was fundamentally more important. And there's a recent quote by Tom Coates, who is a designer who works down in California. And what he says is, Romkey's toaster was clever, and it was a technical triumph that took something analog and made it digital and made it widely connected. But the Trojan Room coffee pot was useful, right? It was useful because it understood that physical spaces and almost all appliances and devices in the world are social, and they're shared, and that fundamentally, above everything else, they have to operate in a world full of humans. So very similar to the quote by Weiser, about the relationship of humans in this is really, really integral, right? I mean, ultimately, this is our world, and we have to live with them, but it's more really about us. And in some ways, it needs to be, right? I mean, and IoT, when you read magazine articles and you think about how, kind of the narrative around IoT, right now there's a lot of promise. The whole idea is IoT is going to make our life better in some sort of way, right? So from self-driving cars, there's so much promise around the idea of self-driving cars, other than the concern about everybody losing their jobs. But there's the issue of, all of a sudden we're going to have reduced congestion on the streets, and it's going to use urban resources in a more equitable way. And maybe we won't have to, all of us, buy cars. Maybe we can just use them when we need them. And there's all these, these social effects that hopefully the net effect will be a really positive thing on society. And you see this on the healthcare side as well with all the IoT devices. And the idea is that, you make use of technology to make life better for people, and everyone will be healthier and happier and more productive. And, that's kind of the promise, at least, of the way it's been kind of pitched and what people hope. And right now, however, IoT, when you look at the hype cycle, certainly is always an interesting diagram. IoT is at the very top, and it is just literally about to fall off the cliff into that trough of disillusionment, right? And I think from a consumer perspective, that, in my opinion, is very much where we are. At the consumer level, it doesn't feel terribly strong. And part of this, I think, is that, on an industrial perspective, it's a lot easier to understand what the value is. It's really easy to say, okay, well, over on the left here, you've got one of those little Kiva robots that works in the Amazon warehouses, And as soon as you see how they work, you can totally understand how they are extremely useful, and how the fact that they are networked and that they go off and do a little task and come back and give the person things that they can pack. And sometimes they lift them up so the person doesn't have to lean over all the time. There's all sorts of reasons, health, productivity, and so on, that those robots are useful. And over here, you have an autonomous truck that works in some of the mines. I think this is in Australia primarily. They've got convoys of autonomous vehicles. And here, again, you've got health and safety issues. You have all sorts of issues where it makes sense, and you kind of see the pitch, and you say, I get it. This is a good use of technology for people and to do interesting things. And then you look on the consumer side, and you often are back to these examples that are, a lot less clear as to why they're really there, right? A lot like Romkey's toaster. And a lot of these objects that people are designing right now, they're beautifully designed, they're often expensive, and they have internet and sensors and connectivity, and sometimes, fairly often, this has been kind of bolted on, right? And it's, this is very much the way things are currently. And a lot of these objects as well, when you think about their relationship with people, they're often designed for a very long-term and kind of exclusive relationship with people, where the idea is that the toilet is something that everyone can use, but if you want to use the real smarts of the toilet, and that is a smart toilet from Japan, it has all sorts of sensors and it analyzes all sorts of things. And the relationship, that long-term, deep relationship where you get the real smarts of the object, is something that you need an application. You need to download the application, set it up, and you need that before you can benefit from the smarts. And so that is often the pattern with a lot of these objects. And some of these, actually, the pattern is even worse than that. With some of them, you can't do anything with the object until you download the app and set it up. The relationship is a lot less, it's a lot more confrontational, in my opinion, and it's certainly not the way that we think of the web. So while Romkey's toaster and a lot of these objects today, they're undeniably of the internet. They are connected, and that's a really amazing thing in and of itself. But when you think of projects like the dangling string, and you think of the Trojan coffee pot, to me, those actually feel of the web. And I don't mean that from the point of view of the technologies they use, but the values, right? The values and the opportunities that they represent and what they enable. And a lot of it simply has to do with the values that we think of the web, right? It's immediate, and it's inclusive, and it's user-driven, and there's serendipity involved. You can just discover things randomly. And it's ephemeral. You can then walk away from something. You're not keeping this relationship automatically. You don't have this fragment of the relationship still on your device unless you want it. And it's very extensible, and it's usually unobtrusive as well. And this is how we think about the web, but at the moment, it's not necessarily how we think about IoT. So I am not at all suggesting that all of these products don't espouse to these values, but one thing I do know is that a lot of these values come almost for free, right, when you create experiences using the web. That is pretty much baked into the web. And so we're getting to this interesting point where a growing number of technologies are starting to converge that could enable us to actually embed these values into all the very way that we think and we build for IoT. And so that's what I'm going to discuss next. And now we just a few minutes ago did hear about some of these technologies already. I'm going to look at them a little bit more deeply in terms of how they work, but I'm also going to talk about the content aspect, the experience aspect, and what we can really do with them. So, as you already know, the physical web enables you to see URLs that are scattered in the environment around you. The technology itself is really, really simple. It's so simple that, in some ways, like a lot of web standards, it doesn't do very much, but does it in a really neat way. So, two parts. It has the beacon, and so we've already actually seen a beacon here. There's a lot of beacons out there. And the beacon, really, the job of the beacon is to broadcast a URL. And then on the flip side, there's the scanner. Now, the scanner, at the moment, are all web browsers, and that's a good thing, because everyone has a web browser. So ideally, once physical web is supported in most mainstream browsers, anyone will be able to just pluck these URLs out of the air. But technically, the scanner could be other things. We'll talk about that in a second. So the way the beacons work, all beacons have to have a power source, and they have a Bluetooth low energy transmitter on the inside, and then some sort of container to contain the whole thing and enable you to stick it on a wall. This beacon here is made by a company called Estimote. There are tons of different beacons out there. There are great big ones that you actually plug into the wall and that are more for industrial use and that are water resistant, dust resistant, and so on. And then there's teeny tiny ones. Just yesterday, a company called Contact.io in Eastern Europe, I believe, released what they're calling a credit card beacon, and it is literally 2 millimeters thick. And it's the size of a credit card. I mean, it's so thin. It's basically kind of like this, but about half the size. And somewhere in there, there's a battery, and it lasts about 8 months. And that's probably the smallest profile beacon I've seen so far. But I've also seen other ones that are thicker, but that are really, really tiny, like the size of a coin. So they've been really, literally all shapes and sizes. And the idea is that there's so many different uses for them, a lot of different contexts. And some beacons also have extra things in them. They have sensors. So while it is also broadcasting the URL, because it's a device and it's got a chip, you can also have it do other things. So it can check the temperature. Some of them have accelerometers. And the more sensors you pack in there, the more you can do things at the same time as broadcasting the URL, which starts to make it really, really powerful. And so also, we mentioned Bluetooth. So it runs at the moment, it broadcasts on Bluetooth LE, which was the easiest thing to get it started with. And there's a lot of devices that support Bluetooth LE now. Most smartphones do. So it's a really good standard to start with. They are already experimenting with other ways. I mean, the idea is that any other type of broadcast medium that would work is fair game at this point if they can find a good implementation. So the Google team who started the Physical Web project right now is working on an MDNS version, which is like Apple's Bonjour. Basically, it works over Wi-Fi, and it would enable you to broadcast over Wi-Fi. Once you connect to the Wi-Fi network, you could then see the URLs. The other thing they're looking at is Wi-Fi Direct, which is actually quite different because with Wi-Fi Direct, you would actually broadcast from one device to another device. So you could actually almost probably broadcast from a phone, for example, and it would become a beacon and then broadcast to other people. So there's probably going to be other ways to broadcast, but for the moment, Bluetooth is pretty much ubiquitous, so it's a really good one to start with. Now, the thing is, even though right now we have beacons, the general idea in the long term is that we don't necessarily need these physical things, right? So again, if you think that a beacon needs to have a power source and it needs to have a Bluetooth radio, there's all sorts of other objects we own that already have that, right? Like the Mac has that, for example. Your TV probably has that already. So there's no reason that you couldn't take the physical web specification and actually just build it into all these other devices. So, a few years from now, you could have vending machines that broadcast URLs. You could have your television that broadcasts the URL that you can go and look at the instructions for the TV, right? So you can start to embed this in things, and the idea of things that you stick on walls will probably start to recede, or at the very least, it will coexist with all these other types of ways, other types of things that broadcast URLs. Now, in terms of okay, how does the beacon work, right? What does it do? What does it do? And again, really, really simple. All the beacon does is it broadcasts, right? It broadcasts the URL at regular intervals, and it has a range. You can edit the range. For most of these beacons, you can program it to have different ranges, so you can have it really close. So only if you're standing really close to it would you actually be able to grab that signal. Or I think the longest ones right now are maybe about 200 or 300 meters, so it could actually broadcast quite far. So for a theater like this, you could have one in the room that could conceivably touch everyone. But you might have one related to this desk, for example, if you had things that related to the AV system, right? So you could put them in different places and therefore use them for different things. And so the beacon broadcasts, and then the user's browser just grabs it. As soon as you're in range, basically, of that signal, your browser can grab it. And if there's other beacons around it, it creates a list, and then you will see, all the URLs. And the way it currently works, the browser also acts as a bit of an advocate for the user at the moment, because it grabs that URL, and it could just show you the URL just as it is, but that wouldn't really give you a whole lot of information about what this thing is. And a lot of times the URLs are shortened, so really you wouldn't really know what this is just from looking at a URL. So the browser goes up to the web, and it actually goes to the page, and it fetches the favicon, the description, and the title, brings them back, and populates them into a pretty list so that the user actually knows what is going on. In doing so, though, it also does one other really important thing, which is actually keeps this barrier between the user who's walking by and that website. Because the only entity that's interacted with that website to grab the favicon and so on has been the actual browser and the little server proxy that it has. And so when the user looks at that list and then decides what they want to do, they could look at this and say, none of these interest me, and they'll just keep walking by. And so no one really knows that user has walked by, right? It's creating this privacy barrier where the only fragment that is left of that interaction is the browser going and grabbing that information, and then nothing else happens after that. If the user doesn't want to follow the link, that's fine. And so they've built a lot of things like this in so that from a privacy perspective, even though all these devices are broadcasting, it's like the web. Right now with the web, if you don't want to open your browser, if you don't want to go to a website, there's no one stopping you from doing it. There's no one pushing information at you. And there's certainly no one snooping when you're not yet on a website. And they wanted to keep that barrier as well. So until the user actually clicks and goes to that site, they are invisible. And then once they reach the site, then they're subject to all the usual stuff on the web, like they might have a cookie that identifies them and so on. And so that is really it, right? All subsequent interactions between the user and the site take place on the web. The user doesn't communicate with the beacon, they don't exchange information, none of that goes on basically. It really is just a pointer. It's a pointer that you can grab out of the air and then do something with once you get to that site. Now, the browser support at the moment, it's pretty good actually when you think about it, considering that the standard, or the spec has only been going for a little while. So it is fully out there on Chrome right now, which supposedly is about 800 million devices. That's quite a good amount. And it also works on Chrome for iOS. Opera has a labs version. Mozilla has a beta. Edge, I'm not sure yet. I've heard that it might be coming soon. The outlier, obviously, is Safari. We don't really know if or when they're going to support it. What's interesting, though, about the physical web really is it still is just a specification. And even though the browser is the obvious candidate, because we're dealing with URLs, the browser is the obvious thing that would grab that URL and do something useful with it. And certainly from the point of view of openness and universality, the browser is the best candidate because everyone has a browser. In theory, you could also build physical web into regular apps. So for example, Facebook could support the physical web, right? And it could become a scanner. And so when you're walking around, you could either have your Chrome browser that opens it, or you could technically have Facebook. Right now, we don't really know what direction all this is going to go. It could stay very much in the web envelope, but there's no reason that you couldn't have other apps supporting it. And for certain apps that are big and widely distributed, something like a Facebook, like a WeChat, Alibaba, and so on, where you have 800-900 million users, over 1 billion for Facebook, it is kind of a secondary browser for a lot of people, whether we're comfortable with that or not. So we might see the physical web actually supported in a lot of other places. The other thing that's worth considering is, this is a little bit kind of out there, but we're used to the browser being a thing on a screen that displays text, right? But a URL right now is just a signal that's being broadcast out there. There's no reason that you couldn't start to make devices that actually grab that signal and do something else with it. And if you think about how Pokemon works, it's kind of a neat example because they've actually made a little watch that as you're walking around, if you get to a spot where there's a Poke something, the watch will start to light up, right? So, what if you had a watch and every time that you're walking around and there's a physical URL, a physical web URL, your watch were to light up? That's probably not a really good scenario, but there are probably other things we could do now that we have the ability to actually scan for URLs in the air, right? Things that we've never really considered in the past because it was always go to a URL bar, type something in, or do a search. And that was the only way that it worked. So the thing is, okay, so you broadcast this URL. At first glance, that doesn't always sound very exciting because it is just a website on the other end. But when you start to think of, you've got the website, you've got a location, and then you've got a time. And I think the time is a really interesting part because you've got this little unit of characteristics, right? And you start to align those, you can do really useful stuff. So the very first thing you can do, fairly obvious, is to deep dive to a piece of content that's more useful for that location and for that period of time. So in the case of all these poor people in the London Underground, what they often want to do is look and see which trains are delayed. And even the London Underground has, whoops, they often have these big posters, these big lit up things that are dynamic, and you can see which areas are delayed. Except in this big room full of people, you might only have like a quarter of them who will see that sign. So now you could just broadcast that URL, and the minute you open that page, that's the first thing you would see, which is often the first thing that anybody wants. But that is still pretty simple, right? And so the way that it's useful to think about it is that the real big superpower of the web is that it's extensible, is that you can layer technologies to progressively enhance the experience. So what could you do in this case? So the first thing you could do, for example, is say, okay, and we live in a world full of sensors and things, right? So you calculate the number of people in the room and you try to figure out what the wait time is. You could do that with sensors on the floor, you could do that with CCTV cameras, which are no doubt already there, and a little bit of machine learning to count the number of heads and say, okay, we think there's a 12-minute wait. And then give the user an option, right? What do you want to do? How about we send you a push notification if the wait gets higher? And then all of a sudden, you've really supercharged that interaction. Not only have you given them information, but there's actually something active going on and something that's really, really useful. And it is just a web push notification on top of that URL. It's not much more that you've done. And then you could also start to do stuff like this, right? So use WebRTC and give them an opportunity to have a live chat. If they're lost and so on, right? So any technology, any web technology can be used to enhance over top of this really simple delivery of a URL. But there's so many of them right now that are kind of hitting that sweet spot, right? The camera API, service workers, web notifications, WebRTC, progressive web apps, and then web VR and web AR, right? So you could just pluck a little VR experience, so to speak, out of the sky and have a look. There's a lot of ways that you can kind of intersect just that simple URL with really different experiences. And the idea really is to try to create experiences that have something to do with the location. They're highly situated, but then also they're small and they're context rich, right? It's not about basically dumping them to the home screen of your web page. It's what can we do to make your experience in this space at this time so much more interesting. And I've used the example here of Snapchat Geo Filters. They are not web-based, but in some ways there's no reason that they couldn't be, right? So the way the Geo Filters work is you say, okay, I'm going to put a Geo Filter above this theater, mythically above this theater at this spot, and I'm going to say that it's going to be the Geo Filter for ColdFront, so it will be only active today because tomorrow everyone will be gone. And so anyone who would be in this room would open their Snapchat app and they would see this Geo Filter, which is all these little illustrations and there's little animations and things, and you could take a Snapchat photo. That is a situated experience. It's time dependent, it's location dependent, and there's no reason we couldn't start to do things like that on the web. And the trigger part of that, the discovery, really is the physical web. Now, the other thing the physical web can do beyond just beyond dealing with the internet or the web layer itself is you can use it to expose and kind of initiate interactions with actual physical objects. Now, this is not web Bluetooth. I'm going to talk about that in a second. This is simply using the web to mediate interactions. So in this case, you have the nice people at Panic Software in Portland. They make Coda and Transmit and so on. And a while ago, they made a new sign for their building. And rather than just have a normal sign that lights up and that's it, the top and the bottom of the sign were kind of like little components, and they each responded to different signals. And so what you can do is you can go to this URL. It's just a public URL, sign.panic.com. You could do it right now if you wanted. And you could pick the color that would show up on the top and the bottom of the sign. And, right now, people in Portland who are walking by, they have no really easy way to discover this. I mean, they see the sign, but they don't necessarily know what's going on, right? So if it were broadcasting a URL, all of a sudden you've kind of deep dive people into the ability to interact with an actual physical thing. And again, we haven't really been able to do that so far. And part of it is creating that discovery. And all these little experiences that could be still very ephemeral, like the web. You walk over, you play with the sign, you walk away, right? It's an ephemeral experience. It doesn't require an app download, but it's kind of fun. And it starts to involve more and more people in the physical world. One company that's starting to play around with this quite a bit, I haven't seen them use specifically the physical web, but they're doing so many things that kind of align with it that I would kind of expect them at some point to start using it, is Disney, right? So in their theme parks, they have a lot of people, they have a lot of big pieces of equipment and things like Ferris wheels that they've custom built themselves, and they're finding ways to engage people with these objects at kind of interesting random times. So what happens in the case of this one is you have a light show that goes on, I think, every night. And so if you can imagine, you have 1,000 people gathering for this light show. You have lots of small children. Small children are running around anxious for this thing to start. And so what they do is half an hour before the show, they switch on the Wi-Fi network. And if you open your browser and connect to the Wi-Fi, you automatically get this page, which is actually a game you can play with the Ferris wheel. And so the Ferris wheel lights up and it goes, red, green, blue, and then on your phone you have to match the colors. And if you match them in the right order, you get a point or something like that. And ultimately somebody wins the game, and the person who wins then actually gets to actually kind of interact with the Ferris wheel itself. All that's happening here is you have a web page, and it sends a signal back down to the Ferris wheel and then back up, right? So in some ways, you're using the internet as a proxy for all these interactions. And again, right now, like with Panic, there's no physical web as a discovery point. I think they simply have signs up and they make an announcement. Everybody go to our Wi-Fi access point and start the game. But you could see how having URLs being broadcast would start to make this more discoverable in a random sense, right? And they use the web because, like, in some ways, as the man said, they want to make this as simple as possible. And as simple as possible, the easiest way is to use the web. So Richard already talked about web Bluetooth, and I don't have that much more to say than he does. And he actually had one of these candles, which was great, because every time I've tried to bring one for a demo, it's never worked. So you actually got to see a real live one. I've got just a little bit more about web Bluetooth. I mean, what I wanted to kind of reinforce was the idea that all these technologies are being built to be as safe and privacy preserving as they possibly can. And Richard did already show this, but again, there's no, one of the immediate questions is, oh, well, what if you accidentally connect to an object? What if you're walking by and you somehow connect to the drone, right? Well, the way it's designed, you just can't do that. You have to, first of all, press to connect. Then you get the dialogue, and you can actually see what objects you have. Then you go and you actually connect. And ideally, as a developer, you want to create that feedback chain so the user always knows exactly what's going on when they're connected. And then I do not have a demo, but I do have a video. Let's see if it's going to start to play. Yes, it is. So the thing I wanted to call out here is that the relationship between the user and the drone, right? You need the internet to make the initial connection, because you need to go and grab the website, right? It's like the physical web. The website is actually on the web. But the interesting thing with web Bluetooth is that once you've got that website on your phone, the actual interaction between you and the drone is local, right? It doesn't need to pass through the internet. So if that application on your phone were a physical or a progressive web app, you could cache it, and then it would always be there. And then in theory, the next time you go to interact with the drone, you wouldn't need an internet connection at all. You could be entirely offline, and then you're just talking to the drone, basically, and that's it. And that's another example of how a lot of these technologies can kind of build on each other. Yes, you can use the web for a Bluetooth connection. That's great. But then if you actually make an app that they can save on their device, then all of a sudden it opens up all sorts of interactions that that you wouldn't otherwise have. They could go out into a park with no 3G, and they could still use the drone. And I think that's really, really neat. So, is that loading? Yes. So you kind of look at what we're at, right? We've got the values of the web and what we're trying to do with IoT, what we're hoping to do with IoT. And then you've got all this new stuff, and a lot of it really aligns really well. There's so many different ways that you can kind of initiate interactions with the real world, and whether you're directly interacting with the device or whether you're using the internet to mediate it, there are so many creative ways that you can use it. And using the web, choosing to use the web, and that's the thing, is right now it's a choice, because most IoT, most connected devices just don't use the web. You've used an app. But choosing the web, it enables you to not just expand the possibility space for IoT, but it also kind of compels you to kind of rethink the very shape of the web itself. I mean, we're still very much thinking big right now, right? Websites, architectures, big things. We're trying to make the content as small as possible, but often the containers are still pretty big, and the site that you're accessing is still a website, right? But in some ways, a lot of these interactions that you can start to initiate with the physical world, they could be really small. They could be nonlinear, no architecture, right? Distributed and serendipitous. They could just be a chunk of content at the end of a URL that you just encounter and that you interact with. I'm not sure if that's actually playing, it is. And then you walk away from it, right? So it could be a way to completely rethink how big a website has to be, what it actually has to contain before it's a valuable experience, because it's situated, because it's contextual. So to close, I'll leave you with just one request, right? Start today, if you can, if you're interested. Take some time to get to know some of these new technologies and how they can enable these pathways between the web and the world. And the reason I'm saying this is that we're already at a point where by 2018 there will be more connected things than mobile devices. So there are a lot of connected things out there. And all the social norms, the business models, all of these structures that will drive these future things, they're not just going to define our relationship with the spaces around us, which they will definitely do, but they will often also define the very way that we live our lives. You know, there's a lot of different things being imagined right now. And so far, the web hasn't had a part in this conversation. And these lives will be surrounded by often actors that we cannot see, right? This is that Eddystone, or that Estimote beacon I had earlier that's maybe about this size. That's the chip for the next one, right? These things are getting smaller and smaller and smaller. So we won't know that they're there. We often won't be able to control them. And we won't always completely understand them. So choosing the web as your material, your primary material with which to explore all these experiences in the physical world, it doesn't just enable us to create these really nice experiences, but it also enables us to start challenging some of these narratives, right? And to take a step towards a future where the web's values, all of those things we absolutely love about the web and are so important, are baked into the way we look at IoT as well, right? So inclusive, serendipitous, ephemeral, shareable, and absolutely universal. I'll leave you with a quote from Ursula Le Guin, which technology is the active human interface with the material world. And I would say the web could be that as well. And thank you very much.